Okay, for the derivative of secant, use the reciprocal property. This is the reciprocal of cosine. Okay, use this formula again. Or when f is 1, this is 0. Minus and minus, minus of minus is plus. So this is the product of the reciprocal of cosine and the quotient of sine and cosine. This is secant and this is tangent. So the derivative of secant is secant tangent. Okay, the last one, again we use this formula. Or this is exactly a special case of this one. When f equals this constant function 1 minus sine squared. The derivative of sine is cosine. Minus 1 over sine times cosine over sine. So this is minus cosecant, cotangent. Okay. All of these 6 formulas are important. Will be used in the future arbitrarily. But here, minus and minus is positive because there are 2 cosines here. One here, one here. Sine x. And by definition, the reciprocal of cosine is secant. I think you still remember Johnson's rule. Sine, cosine, tangent, cotangent, secant, cosecant. Here is Pythagorean property. Functions opposite this one is they are reciprocal to each other. So 1 over cosine is secant. And the sine over cosine is tangent because 1 equals 2 over 3. Sine equals cosine over cotangent. Cosine equals cotangent over cosecant. Oh. Secant comes from this one, 1 over cosine. Oh, no, I use this because this is 0. So this term is 0. We have a minus sign here. minus sign here, and f prime is 1. So this is a special case of this one. This sign here. And this is g prime, means the derivative of cosine is minus sign. Minus sign, so we have two minus signs. You can apply this, but in fact, we derive this. This is a consequence of this one. We prove this first. They use this to prove this. Yes, 0. So this is 0. So we skip this term, and this is 1. Yes, so minus and minus is a positive. Good. Yeah, so last week I strongly recommended you to repeat what I have written on the blackboard. Yes, because you have to practice and practice to familiar with what you have learned. I have taught. Maybe I derive these formulas too fast. Okay, but it depends. It depends on whether you are familiar with the basic objects or not. Of course, you can just listen, just get, but you have to repeat after school, or otherwise everything becomes strange, or even seems didn't learn. No problem. Okay, so we have two minus sciences. Signs, S-I-G-N, two negative signs. Okay, so you have to keep this in mind, in your mind, always. Because every formula, every property you have learned is important. I hope everyone can concentrate, focus on here as this gentleman. It's because shows someone really follow what I teach or taught here. Okay. Let's see some examples. Example 1. Differentiate this function. This function is a product of two functions. One is the square function. Another one is sine function. So we use the differentiation rule. Derivative of this one, this is the power rule. Here, n can be any rational number. Derivative of sine is cosine. differentiate this function, for what values of f does the graph of f have a horizontal tangent? Anyway, we find the derivative of this function first. We use the Cauchy rule. Differentiate secant, we have secant tangent here times the denominator minus secant x. Differentiate this one, constant 0. And the derivative of tangent secant squared, secant tangent squared minus secant squared. Okay, here we use the Pythagorean identity. Secant squared minus tangent squared equals 1. So this one is a minus 1. Okay, this is because one plus tangent squared equals secant squared. Therefore, tangent squared minus secant squared is minus 1. So the difference of these two terms is minus 1. Yes, so this is the derivative of f prime of x here. For what values of x the graph has a horizontal tangent? Though we don't know the graph of this function, but we can answer this problem. At some position, there is a horizontal tangent line to this curve, means the slope is 0. So we solve this equation. This one, okay, there's a fraction or a. This one is 0, means the numerator is 0, but the denominator is non-zero. Because secant is the reciprocal of cosine. Cosine, the values of cosine is always therefore non-zero. So this non-zero. Therefore, in order to let the left-hand side to be 0, tangent x equals 1. And if tangent x equals 1, of course, 1 plus tangent x is not 0. Because 1 plus 1 is 2. So this equation is equivalent to tangent x equals 1. Tangent x equals 1. Tangent equals sine over cosine. When